In the development of complex mechatronic equipment, many issues are only discovered after the machine is assembled: motion interference, incorrect cycle timing, sensor signal errors, and mismatched PLC control logic. VMC, the Virtual Mechatronics Commissioning Platform, is designed to solve these problems earlier. The first core capability of VMC is virtual commissioning based on native SolidWorks models. Engineers do not need to export the model to a third-party platform and rebuild it from scratch. Instead, they can continue defining motion relationships, mechanism logic, and commissioning objects based on existing mechanical design data. This keeps mechanical design, motion validation, and control commissioning within the same engineering dataset. In VMC, users can define motion joints, actuators, and motion parameters for machine mechanisms. For example, cylinder extension and retraction, slide movement, gripper opening and closing, conveyor operation, and rotary positioning can all be configured in the virtual environment. With these definitions, a static mechanical model becomes a virtual machine that can run and be commissioned virtually. Virtual commissioning is not only about making the model move. More importantly, it connects the model with control signals. VMC supports the definition of sensors, limit switches, detection points, and actuator signals, and maps these signals to PLC or HMI control logic. When the virtual mechanism reaches a specified position, the sensor signal can be triggered. When the control program outputs an action signal, the virtual actuator can respond accordingly. VMC helps electrical and control engineers perform joint commissioning before the physical machine is built. Engineers can validate PLC control logic, HMI operation workflows, machine action sequences, and abnormal handling processes in advance. This means many issues that would normally be found on site can be discovered and corrected earlier in the virtual environment. During commissioning, VMC can also be used to validate motion paths, cycle timing, mechanical interference, and abnormal conditions. For example, sensor failure, actuator mispositioning, incorrect action sequences, and material jams can all be simulated in the virtual environment. This helps teams improve control strategies in advance and increase the reliability of equipment delivery. The commissioning results from VMC are not only useful for the current project. They can also be accumulated as digital twin assets. Models, motion logic, signal mappings, abnormal conditions, and commissioning experience can be reused for training, maintenance, upgrades, and future projects. From mechanical models to motion definition, from signal mapping to PLC commissioning, from abnormal validation to digital twin asset creation, VMC enables complex mechatronic equipment to be verified, commissioned, and optimized before it is built. This is a virtual mechatronics commissioning solution for SolidWorks users.